Hello students, today we are going to start the third part of the chapter of magnetism, and in this video we will see how to plot uniform magnetic field and obtain the neutral points. Let us start with the Earth's magnetic field. So for plotting the Earth's magnetic field lines, what we will do, fix a sheet of paper on a drawing board by means of pins, place a small compass on the position 1, this is the position 1. If you place a compass, this north pole will be pointing here. Now take a pencil and mark the end, mark the tip of the north end of the compass, and again you pick the compass and place it here. Again you will similarly mark the tip of the north point here, and this way you go on. You will again after some time you take the compass and start from nearby end. So you will see parallel equispaced magnetic lines. You will see parallel magnetic lines fields. These magnetic lines fields are parallel, which means that there is a uniform magnetic field here. Here the magnetic field is uniform. So this suggests that Earth's magnetic field is uniform at a point. Now let us do something else. Now here you can see there is a bar magnet, a horseshoe magnet, two magnets with opposite polarity and two magnets of same polarity of facing each other. Now here you can see the pattern of lines of force is not like this. As you can see here there is a cluster of magnetic field lines, here there is a cluster, but here it is separate, far away. So this cluster suggests that at this point the magnetic field is very strong, and here the magnetic field is not as strong. So wherever you have the density of magnetic lines of force more, it suggests that at their places there is a strong magnetic field. Okay. Now what is the direction? Direction, so we know lines of force always emanate from the north pole and move towards the south pole. They migrate from the north pole to the south pole. Here also north to south, north to south. Okay. Now if I place two opposite poles facing each other, then the pattern will be also same, north to south, north to south. But here the lines of force will repel each other. Okay, lines of force will repel each other, and this point here we will have a neutral point, means the place where the magnetic field of both magnetic field of this and magnetic field of this are cancelling each other. So here we are having a neutral point. Okay. So we will discuss the procedure of plotting the non-uniform magnetic field lines of a bar magnet. So this is the pattern that we can obtain. Now we will see how we can plot the non-uniform magnetic field line. See, we have kept a bar magnet with north pole facing towards the north and south pole towards the geographical south. With the help of magnetic compass as the method, you place the compass here and go on pointing the tip of the compass. Okay, suppose you place the compass here, you put a dot on the tip, again you place a compass here, put a dot on the tip, and this way you go on, you will find such type of lines of force. And here along the perpendicular line to the axis, this is called the axis of magnet. So perpendicular to the axis we will find the neutral points. Why? Because here and here the magnetic field due to this magnet is neutralized by the magnetic field of Earth. So these two cross, where you can see the cross, these two crosses are the position of the neutral points. Okay. So just keep in mind, when the north pole is towards the north, then the neutral points are on the perpendicular direction, on the perpendicular bisector, okay, to the axis. But if we reverse the direction, if I keep the south pole towards the north and north pole towards the south, then and I do the same thing, same plotting, the lines of force will be almost similar, but you can see the neutral points will be along the axis. It will be along the axis of magnet. The neutral points are now not on the sideways, they are on the axis. Okay, so they are along the axis. Okay, so if I place, so what will you keep in mind? If you place the magnet with the north pole towards north, then the neutral points will be in the east-west direction. If I place the, okay, but if I place the magnet in with the south pole towards north, then the neutral points will be in the north-south direction. Okay. Now, neutral points. Neutral points, as we have discussed so far, neutral points are the points at which the two magnetic field equal in magnitude but opposite in direction, and hence the net magnetic field at that point is 0. Means at one point there are two magnetic field. These two magnetic field can be due to two magnets, can be due to one magnet and Earth's magnetic field. Okay, whatever. These two magnetic field can have any source, but there should be a two magnetic fields, and these two magnetic field at that point are opposite in direction and equal in magnitude. Hence, the net resultant of the magnetic field at that point is 0. So, that point is called the Earth's magnetic field. Okay. Horizontal component in a direction of geographical south to geographical north. Okay. Our Earth has two components. The magnetic field of Earth is divided into two parts. One is called the horizontal component, that is in the north-south direction, and one is the vertical component, that is vertically downward, that is called vertical component. Okay. The position of neutral points or neutral points in some cases are given below. So, see, for two magnets at a separation in one line with like pole facing to each other, the neutral points is between them. This we have already seen in this diagram, that if I two magnets like pole facing each other, then the neutral point will be here. Suppose this is a magnet, north pole facing each other, then the what will happen? Then their neutral points will be somewhere in between the magnet. This is the first point. Okay. For two magnets standing vertically with north pole up, with the will be some point on the vertical line away from its north pole. Okay. So suppose if I have two magnets standing vertically up, then their neutral point will be somewhere on the vertical line away from the north pole. And third point, as we have just discussed, neutral points situated symmetrically on either side of a magnet at equal distances in the east-west direction if the north pole is facing towards the geographical north. Means they are wanting to say this. If I place a north pole facing towards north, then the neutral points will be in the east-west direction. And the fourth number point is the neutral point are either side on the magnet in the north-south direction if the south pole is towards north. So, they want to say this one. This is the fourth point explanation, this diagram. If I place the reverse case, the south towards north, then the neutral points will be in the north-south direction. Okay students, study the chapter properly, and whatever you have doubt, you can ask me in the next live class. And this chapter is completed because the next part, electromagnetism, is not in the reduced syllabus. Okay students, have a nice day.